Hello everyone and welcome to this ChangeCockpit deep dive all around email security. Already the second deep dive of this year and the fifth deep dive for ChangeCockpit in total. My name is Rolf Tröndle. I'm a Microsoft Cloud consultant and MVP, also founder of ChangeCockpit. And in the live version of this deep dive, I also have a moderator, Drago Petrovic, a fellow MVP, but the live edition is currently only available in Swiss German. From the agenda of today's deep dive, first of all, I want to set the scope and overview of this session. Then DANE and DNSSEC is the first part. Then we go over to MTA-STS protocol, validation and authentication technologies like SPF, DKIM, DMARC, and ARC, and then an announcement of the next events, next deep dive, and ChangeCockpit live events. Last but not least, Q&A. So, first of all, overview. The scope of this presentation, it is about, because the title, email security or all about email security could also mean we are talking about mail security regarding encryption of individual emails. No, that's not part of this presentation. If you are interested in this thing, then just let me a note so we can prepare a deep dive about these protocols or these features. This presentation is about mail security regarding email submission, regarding sending and receiving emails between systems, between servers, between Exchange Online and other external parties. We are talking about the standards and protocols regarding the email submissions, and that's what the presentation is about. You've just seen it in the agenda. It's only about these protocols. So, for a quick overview, first of all, we have for this session, we are talking about DANE and DNSSEC and MTA-STS. These are protocols or technologies used to identify or to apply security. We will see this in a lot more detail just in some minutes. About sending email to, I always use Exchange Online as the receiver because ChangeCockpit is about Microsoft 365 customers. Microsoft 365 customers have their mailboxes in in Exchange Online. And we are talking about sending out of Exchange Online to another receiving server. Receiving servers could also be then another Exchange Online system. So that's what this is about with DANE and DNSSEC from transmission of mails to and from your server or your systems, which are hopefully hosted in Exchange Online, and the validation parts like DMARC, DKIM, DKIM, SPF, and ARC. And these parts are part of the center intelligence stack of Defender for Office 365. We see a lot of building blocks in Office Defender for Office 365 protection, and this particular part in here is about the protocols discussed today. If you want to have more deeper insight in the MDO protection stack and wish another deep dive session about this, please let me a note. Because deep dives are always made on customers' requests, on customers' topic requests. So, first topic of today, DANE and DNSSEC. What is it about? So first of all, DANE is available in Exchange Online since already 2022 for outbound email, meaning if you send your emails to external systems or to external recipients. They could also be hosted in Exchange Online. And now this year, and that's why it's a very hot topic at the moment, at this year we are talking about DANE and DNSSEC supporting Exchange Online for inbound email, meaning when you receive email from other domains. This is currently in preview and will be generally be available in October 2024, so quite soon, or even this month. DANE for SMTP, DANE stands for DNS-based authentication of named entities. What this means in detail, we will just hear in some minutes. And this is based on DNSSEC. DNSSEC is an individual standard which also exists without DANE and is domain name system security extensions. It's also used for other things, but it's the foundation of DANE for SMTP because it relies on DNSSEC. This means what DNSSEC is, we will see on the next slide or just in a minute, but just in case or to note here, if your public DNS provider doesn't support DNSSEC protocol or standard, then you cannot implement DANE for SMTP. So then you would need to use MTA STS, which will be discussed also in this deep dive. This is developed by the Messaging Malware and Anti-Mobile Abuse Working Group. This is an open standard. It's not developed by Microsoft. Microsoft is only adopting this standard DANE for SMTP. And the goal of DANE and DNSSEC or DANE for SMTP is to prove the domain records are authentic. So if you send an email or if someone sends an email to you, they want to know that these domain records in your DNS, in your public DNS is valid. It's not tampered with. There is no man in the middle and so on. And you can prove this using DNSSEC, and then you put inside your DNS, you add there a TLS-A resource record, and this resource record forces DANE to be used, and DANE by default will then force TLS to a trusted certificate when talking to your servers with SMTP, meaning when sending emails to you. So the DNS is not tampered with, and it's a valid and it's the right TLS certificate found at the destination. You solve the problems like the TLS for SMTP is today only opportunistic. This means, and that's for a long time, and it doesn't matter if it's Exchange server on premises or Exchange server in the cloud. If your Exchange server sends an email to an external recipient, it will try to use the best possible TLS version. So if it's enabled on your server or on your Exchange Online systems, that's currently 1.3. If the other system supports 1.3, TLS 1.3, then this email will be sent. And even if the receiving sender, if the receiving server only has an self-signed or not public trusted certificate, it will just be sent using this certificate and secured by this certificate, even if it's untrusted. So at least it's TLS encrypted. That's opportunistic TLS. And if the receiver or if the other system doesn't support TLS at all, because perhaps it's a very old system, then Exchange Online would even send it without TLS. So that's opportunistic. This means it will use the best possible solution, but it's not enforced to have a trusted certificate, and it's not enforced to use TLS. You could use, or you could do this currently in Exchange Online using a partner connector, but then you need to do this for every, you could use a star partner connector, but if the if the recipient doesn't have TLS at all, then your email wouldn't be delivered. So doesn't make any sense in this case. So this opportunistic TLS with TLS-A records, you would signal to the sending server or to the sending server needs to use TLS because it's signaled using a TLS-A DNS record. And TLS downgrade or man-in-the-middle attacks and DNS cache poisoning attacks aren't possible anymore because we are using DNSSEC to prove or to validate that the TLSA resource record is in real and is valid at all. Okay, I hope this is a bit clear. We will see this even in more detail. I have flows and flow charts just in some minutes. First, Dane and DNSSEC outbound in Exchange Online is, as mentioned, it's available since 2022 and it's by default it's on. So if you're hosted in Exchange Online and your emails are sent out by Exchange Online, meaning you don't use centralized transport, then Dane and DE will be used if the receiving party supports it. This is available and enabled today. For inbound, meaning when you want to receive Dane secured TLS connections to Exchange Online, then it needs manual configuration. So you would need, as mentioned, DNSSEC in your DNS provider and a TLSA a resource record. Then afterwards, you need to enable DNSSEC for the verified domain in Exchange Online. This is also needed because when you use Exchange Online, your MX record is a CNAME record to an MX hosted in Exchange Online. So this zone or this record also needs to support DNSSEC. Then you will change the MX record. We will see this in more detail later. And then enable Dane support in Exchange Online. So it will offer Dane support to the sending or to the third-party system. And this is part of Dane and DNSSEC, and there are also reporting options available. TLS RPT reports, that's kind of optional. Just if you would like to have these reports, then you would add another TXT record in your public DNS called smtp-tls example.com, and then you specify the email address where the reports will be sent to. This is like for DMARC. We will also see later for DMARC. So if you send out emails and the receiving system. So let's say you send out an email to contoso.com and Contoso has enabled Dane and DNSSEC for themselves, and you add this record here for TLS RPT in your DNS server, then the receiving server would see, okay, you would like to have a report, and once a day it will send out a summarized record to this email report to this email address, which you can then analyze to check if all your emails went well through and if they were secured. Normally for these reports, also for DMARC reports, you would use then in there a third-party reporting analyzer software. Just to note, you can also have reports for Dane and DNSSEC and also for MTA STS. So first of all, the foundation of Dane and DNSSEC is the zone, the DNSSEC secured zone. So DNSSEC, what's DNSSEC? A simplified explanation. For you have your public DNS zone that's called for contoso.com. This DNS zone will be signed. You have zone signing enabled. This means, let's say you have your MX record in here, then these MX records will get an RR6 resource or an RR6 signature entry. You also have for this zone the DNS key for this zone with the public key of the public-private key pair used to create this signing record, this RR6 for this MX record. This means a DNS resolver who wants to send to you will get your MX record and is now able to calculate the signature of the MX record using the DNS key, public key, or no, it's not able to, sorry, it's not able to calculate it by itself. You would need to have the private key, but you can check the signature using the public key provided in the DNS key entry in this contoso.com. This means you will be able to verify the signature in DNS. This means you are able to check if this DNS record is valid. And in this case, the most important record there we would need or we would protect is the TLSA record. But that's the foundation to have a secured DNS request or DNS resolver request. If this fails, then this would fail with a serve fail error. We will see this serve fail error also in the flow later. Okay, that's the DNSSEC part. It will, in short, it will add signatures to your records, and you will, or the other party will be able to validate these signatures using the DNS key provided in this zone. Then we have TLS, I mentioned the TLSA record. The TLSA record, what's the TLSA record? Here we have an example of such a record. TLSA record signals the sending server, the sending system that you enabled DANE. If there is a TLSA record, a valid TLSA record for DANE, this looks like this one here, then DANE will be enforced and will fail if something happens in between. So we see here the TLSA record for 25 TCP MX contoso.com as domain name. And then we have the resource record in here. This resource record or this TLSA record has different fields, usage fields, 03, 01, 02, and certificate associated data. This is a general standard. That's why it's specified like this. But for DANE, RFC states for DANE, there is always a 311. We can see this here in the record. So this record starts with 311. 3 means DANE EE. And they specify only match against the destination server's certificate. And the 1 means subject public key info. Use the certificate's public key. That's the public key specified at the end of the record. And the algorithm with which the public key is identified to use. So you would check for the destination server certificate if it matches with this specific public key. And the 1 means the public key hash algorithm, SHA-256. And this means that you could also use the SHA-128, but that's not in the DANE RFC supported. So that's why it needs to be 311. So this states you would check the destination server certificate, and this certificate needs to be this hash. So you don't just trust the recipient server or the recipient system certificate because it's a public certificate. No, you only trust it if it's this specified hash. So it must be exact this certificate which is stated in the TLSA record. And to ensure that this TLSA record is valid, we use DNSSEC. So in combination of these two fields, we are sure we are talking to the right server, and we are sure this server or this DNS isn't tampered with, or there is a DNS cache poisoning in the DNS system. That's why we have these resource records and these RRSIG hashes as we have just seen before. So now we know the server is the right one. How does this work in the email flow when sending with SMTP DANE? So let's say we want to send an email to contoso.com, or Exchange Online wants to send then out the email to contoso.com. First, we query MXA and Quad A resource records. Then we check if serve fail error is generated. If yes, then we won't send it. Anyway, this has nothing to do with SDAIN and DNSSEC. Also, without these protocols, we won't send. We will send back an NDR with error information if we have a serve fail anyway. So then if serve fail error isn't generated, then we check if the domain records are authentic. If no domain does not have DNSSEC configured at all, this means we will fall back to opportunistic TLS as explained before. We will just use the best available TLS option, but we aren't really sure if it's the right destination system. If we have authentic domain records, this means DNSSEC is enabled and valid, then we will query for TLSA resource records. This TLSA record, as just seen, the 311 and the certificate hash, then we will check if one or more TLSA record is returned. No, then we will again fall back to opportunistic TLS, because if there is no TLSA resource record, this means DAIN isn't enabled. So we only have DNSSEC, but without a TLSA record, we still can't use DAIN, so we will fall back to opportunistic TLS. If one or more TLSA record is returned, then we will start the TLS connection to resolved MX host. We will select one of these TLSA, and then TLS connection is successful. No, then we will send an NDR because we are now we want to use a successful DAIN connection. DAIN is signaled by the TLSA record. So if something happens now, we will fail this sending mechanism. So we will send back an NDR to the sender. So if TLS connection isn't successful, we will fail this email and send back an NDR. If connection is successful, one or more TLSA record is usable per RFC. So this, if it's valid per RFC, meaning 311, if no email is sent using enforced TLS, but without SMTP DAIN validation. So we will only enforce TLS by now because there is a TLSA record, but it's not RFC compliant. We will fall back still to at least enforced TLS. Then yes, if its TLSA is usable per RFC, then DAIN validation occurs based on TLSA record values. We will check for the certificate of the receiving server, and if it's successful, then email will be sent using SMTP DAIN, and if not, then we will fail the email again. So that's how it works to send out an email using, or how the mail flow is going. Anyway, this is on by default if you're sending out from Exchange Online today, and if the recipient has an RFC compliant TLSA record, then they will be used. So how do you set this up in Exchange Online? First of all, you lower the TTL of your current MX record, because we will replace your MX records during this procedure or during this implementation. If you are currently also using MTA STS, this can coexist with SMTP, with DAIN for SMTP, then you need to set the policy to testing. You need to increase the policy value. What I'm talking about here, I will explain later in the MTA STS part, and wait for the max H. Then enable DNSSEC for verified domain. You need to enable DNSSEC in Exchange Online for your public domain for which you want to enable DAIN and DNSSEC. This will output your new MX record ChangeCockpit ch.o-v1.mx.microsoft. So this is a new zone, this .mx.microsoft. This was implemented or is implemented during public preview of inbound DAIN for SMTP in Exchange Online, because this zone here now supports DNSSEC. That's why we need to change. You could think now, okay, but if Microsoft is doing DNSSEC for this record, why do I need it? The reason behind this is First of all, you need to have a valid and DNSSEC secured TLSA record in your public DNS, and you still have your MX record CNAME, which is pointing to the secured Microsoft the MX volume. So then you add this new MX record as a new lower TTL MX record with a low TTL. So you ensure that this value, you add this as another MX record into your DNS server. Then you run the test connectivity for MX. This would look like this. You can do this in testconnectivity.microsoft.com. There is an inbound SMTP test. This looks like this, testing inbound SMTP mail flow. And then it will, you now have for sure at least two MX records, the old one pointing to mailprotectionoutlook.com and the new one pointing to this .mx.microsoft domain. Mentioned here, it's .mx.microsoft and not .mx.microsoft.com, because this new top-level domain will be used now for many services in Microsoft 365. So it will then, you need to watch out to test the mail exchanger for this new .mx.microsoft MX record. And if this is valid, we can go on. We can continue with the setup. So we have in Exchange Online the setup. We have swap now MX priorities. This means you need to lower the MX value for this newly created record with the .mx.microsoft. In this example, we need to lower the MX value to 0. And then this will be used, and we will remove then the legacy MX record. We know the MX record is valid. It's also usable. This new MX record is also usable without using Dane. Don't worry about that. You can also just use it as a replacement for this legacy mail protection outlook.com or mail.eo.outlook.com records. So there's nothing happening now. We didn't enable Dane yet, but just swap this out, and then this new record will be used, and this new record enables also DNSSEC. So then you can use the DNSSEC test also in test connectivity, and the DNSSEC needs to be passed for this .mx.microsoft MX record, because it's the new DNSSEC supported zone. Okay, then afterwards, next step, you go to and enable SMTP Dane inbound for your domain name. Now you enable Dane. You need to verify the TLSA records, and these TLSA records for the TLSA record for .mx.microsoft. And if you're using MTA STS, then you need to set the policy back to enforce if you had it to enforce before, and wait for the max age. So then after, this means after enable DNSSEC for your, you get new MX, then setting this new MX as first order as your only MX or your first MX record, and then you enable SMTP Dane inbound. For your reference, here are some NDR failures for outbound email if the recipient system signals Dane support and perhaps doesn't have a TLS certificate installed, then you will get, or your users will get, an NDR with this code. So that's just for your reference of possible NDR and codes for sending email outside of Exchange Online. Now we know Dane, the Dane support, we need the TLSA record, we need DNSSEC to implement this, and we've seen the steps to enable it for an Exchange Online native configuration. It wouldn't be ChangeCockpit or a ChangeCockpit deep dive if we don't have a roadmap of what's coming next for Dane for SMTP. So first of all, since September 2024, we will get an inbound DANE, or we got an inbound SMTP DANE with DNSSEC and MTA STS report. That's a new report in Exchange Admin Center where you can see what's going on inside your system. Then in October this month, we will have a GA announcement that's not out yet. It's currently the 16th of October. I hope it will follow later in the month of the inbound SMTP DANE with DNSSEC support. As mentioned before, it's in preview. You could enable it. Microsoft states as long as it's not GA, you shouldn't enable it for your production domains. And at the end of 2024, Microsoft will deploy inbound DANE support with DNSSEC for all Outlook domains, meaning outlook.com, hotmail.com, and so on. That's just to note. It's nothing to do for you. And the transitioning provision of the mail records, they will switch, or they will only hand out these newer MX record versions for all newly created accepted domains into the DNSSEC enabled infrastructure. This means you have if you add a new domain to Exchange Online, you will always see this new MX. So if you want to enable inbound DANE, afterwards, after you enabled or you added a new domain to Exchange Online or to Microsoft 365, then you don't need to use the enable DNSSEC part for the steps we've just seen. You only need to enable the SMTP DANE inbound. And then starting in February 2025, so next February, you will have mandatory outbound SMTP DANE options. You can set this per tenant or per remote domain. So if you wanted to secure mail flow between you and your partner, your business-to-business partner, you would have added till now a partner connector and specified the expected certificate, and then Exchange Online would only send it out if the specified certificate would match this common name specified in this partner connector. And even if there wouldn't be any TLS, so you would override opportunistic TLS with the partner connector. That's available for years now. But the new option here is you have the possibility to have mandatory SMTP DANE, so to force SMTP DANE for your partner domain. So if something happens in the flow, we have also seen, and it would fall back to opportunistic TLS, it would fail the email sending process. So you will be sure you can send to this partner only when everything is secured by DANE. That's it for DANE and SMTP. The next topic is MTA STS. Okay, what's that? First of all, it's available in Exchange Online since 2022, so it's not quite new. And it's Mail Transfer Agent, MTA, Strict Transport Security, STS. You can also call it the light version of DANE for SMTP. It was developed by the same group, so it's a public protocol again. It's not developed or invented by Microsoft, it's only applied by Microsoft Exchange Online. The goal here is to signal the sender to force the TLS, so overriding opportunistic TLS using a text record in DNS. And the other goal is to prove we are talking to the right server. So in DANE, we prove that we are talking to the right server because we have the TLSA resource record. And here we are proving we are talking to the right server using a policy file. So because we don't need the TLSA resource record, we also don't need the DNSSEC support. So this option is also available for everyone, no matter if DNSSEC is supported in your public DNS zone. You solve almost the same problems as with Dane for SMTP. TLS for SMTP is opportunistic by default. You override this. Then TLS is used for encryption, but not to verify the identity because it's opportunistic TLS. You would accept every certificate, no matter if it's self-signed. And with the MTA STS, you can override this. And so therefore, this means you cannot have a possible man-in-the-middle attack. And you ensure you are using a minimum version of TLS 1.2 because you could have a downgrade TLS attack if you can convince the sending server to use only TLS 1.0, and then you have vulnerabilities in there. You could use these vulnerabilities, but with MTA STS, you are forcing at least 1.2. And you ensure that you are connecting to a trusted certificate. We don't specify the thumb or the hash in there of the receiving server certificate as we are doing in the resource record in Dane. We are specifying only that it needs to be a public trusted certificate. So that's also it's protected in this case, and we replace the DNSSEC part because with a policy file we could look at like this. Okay. Outbound in Exchange Online, MTA STS is default on, as with Dane for SMTP, nothing to do. For inbound configuration, meaning if you want to receive emails protected with MTA STS for your domain in Exchange Online, there is manual configuration. As mentioned, or you need to signal the sending server that you are supporting MTA STS using a text record called MTA STS.changecockpit.cloud in this example for the domain changecockpit.cloud. And in there, you add value equals STS v1. This means this is needed per RFC in this text record. And then you add the ID, the policy ID stamp. You could use our version. Here it's the version. Most of the implementations use the timestamp as the version when you create this text file. So you just increment using, if you add a new policy file, then you just add here the new timestamp, and then the sending server knows there is a new policy file available. But what's this policy file I'm talking about? Policy file, here we see the one for Microsoft. Policy file is a text file, and this text file contains version STSv1, mode equals enforce or testing, and the valid MX records you may use. So if someone is able to do DNS cache poisoning and add in the intermediary DNS server another MX record, with a lower value as an example, and would like to redirect all emails to them, that's not possible because you specify which MX records are valid. And the max age of the policy is also specified. And this policy file will be hosted on a well-known URL. This well-known URL is always, that's specified, it's always in mtasts.domain / well-known/mtasts.txt, and it's secured by HTTPS. Yes. And this means, first of all, you need to have a trusted public certificate to secure this text record, and it's always on this domain name. So this means you would need to implement, if you want to use MTA STS for your domain, you will need to implement a policy file in this URL. This URL is not configurable. That's not possible because it's specified in the RFC and it's part of MTA STS. So instead of having Dane and DNSSEC, we are using a policy file. And in this policy file, we specify the valid MX records. And in this valid MX records, there will also need to use, as mentioned, TLS 1.2 at least for the connection, and there will need to be a public trusted certificate, and and you also need the public trusted certificate even to host this text policy file. So we have multiple public trusted certificates which need to be trusted for MTA STS to succeed. That's the trusting point in here. In this policy file, you could also add other MX records. For Microsoft, it's only this one I just shown you, but you could add more lines with MX and then specify this in there. And as also mentioned in DANE for SMTP, you could add TLS RPT reports. You could request TLS RPT reports for emails you send out using MTA STS to analyze if everything went well. So I mentioned you need to implement the policy file with this URL. You could either host your own server somewhere, or you could use your public website server where you have a trusted certificate and implement this subdomain and host the text file in there. There is also an option from a Microsoft guide that's not supported by Microsoft. It's just written by a Microsoft guide. There is a PowerShell module out there called PSMTA STS PowerShell module. You could install this PowerShell module and deploy an Azure function or an Azure service to dedicated host this policy text file. That's a possibility to do. It's as mentioned, it's not supported by Microsoft. It's only a Microsoft guy who has written this module, and it's widely used. If you would like to use an Azure function to host a policy file, there is a guide, a detailed guide available of a blogger colleague of mine, and there are step-by-step specified how to do this. It's very easy. So just go in there and watch or have a look at this guide. So MTA STS, what's the flow when sending emails? So first of all, the sending server wants to send an email to Contoso. That's the use case. Then the sending server checks the presence of this text file, this text record. And if this record exists, it will fetch the policy from this well-known URL. We also have just seen mtasts.domain. And then it will evaluate the policy to determine the TLS requirements and valid MX hosts, the desired behavior. So this means enforce testing or none. You can have this in the policy if you would use it. If you would like to use it for testing, just specify testing in there. And if you specify enforce in the policy file, so this means if something, let's say in the certificate if the certificate is self-signed, then it will fail the sending, and if it's still on testing or on none, then it will still go through. And then how long the policy should be cached, because each sending email service, which also supports MTA STS, will cache the policy file and would not for every mail sending operation go to your Azure function in an example or to your web server and download the certificate. This makes things easier. We can also see this in this flow. In here, the sending email service will then have check for the MTA policy cache. If the policy cache is there and is still valid, defined by the max age in the policy file, if it's still valid, how long you can cache it, then it will check the DNS record for the MTA STS policy, check the policy if there is a newer one. If it's a newer one specified in the DNS record, we have seen the timestamp as the policy version, then we won't use the cached policy. We would download a new policy if there is a newer time or a newer version available, which is signaled using your text record in DNS. And then we will check the policy and we will send it with enforced TLS. That's the sending part, and the receiving side, that would be you. You would need to implement it using the DNS record and to publish the MTA policy, STS policy file in a web service. And then it will connect to your MX record after having downloaded the policy file, and will check if the criteria are met to connect to your service. It will then, and if you're enforced, then it will send out an NDR if the criteria aren't met. So there's the example of if you get the self-signed certificate and you are on enforce, then you will throw your the sending server will throw an error, meaning an NDR back to the user. These NDRs, like in Dane, this is for your reference, and possible NDRs are 551474 star TLS is required by recipient's domain policy. This means the destination server does not support TLS, just as an example. And there are the other possible error values in here for your reference. Reports, I mentioned the TLS RPT reports. You could implement this and a report would look like this. Organization name, date range, you will see the policy string you get in there, policy domain, the MX host, and then you have the total successful session count and the total failure session count. And you will see more details like the failure details, certificate expired for 34 times, or star TLS not supported, meaning no TLS available at all. You have 200 sessions in there, and you will see which MX record failed this, and you would see this in the report if you would like to have that, and then analyze this. The source of this report here is Volleymail, because they also support, even for free, I think, to have a hosted analysis of this TLS RPT reports. Roadmap, there's only one point for MTA STS, and it was also mentioned in the Dane part. You have the reporting on the reports mail flow, the inbound SMTP Dane with DNSSEC and MTA STS report, which should be available now in your Exchange Admin Center. Now, should you use MTA STS or Dane? Perhaps you asked yourself during this presentation. MTA STS does not need DNSSEC. So if you cannot use DNSSEC, then you have only the option to use MTA STS. Dane for SMTP with DNSSEC is also called the gold standard, but the MTA STS is for most companies it's good enough. And both standards, if you can't decide and you have DNSSEC support, just implement both, because both standards can coexist. But if you are undecided or you wouldn't like to have the complexity of the DNSSEC part, just at least use MTA STS as recommended by Microsoft. That's for the part of Dane for SMTP and MTA STS. Now the next part is about email authentication. Remember this picture from the start of the presentation. We have seen the left part, the SMTP transmission part from the sending server to Exchange Online and from Exchange Online to receiving server. And now it's about the protocols or the standards DMARC, DKIM, SPF, and ARC, which is part of the Defender for Office 365 protection stack. It's about the authentication, email authentication. We aren't talking about basic auth or username passwords here. We're talking about SPF, DKIM, DMARC, and ARC. The goal of this email authentication part is to validate the sending server. So you would like to validate the sending server. The mostly used scenario would be spoofing. There is available Sender Policy Framework. Sender Policy Framework is available since 2003 as a standard. So it's a very old standard, but I've seen many companies still not using SPF records. Then DKIM, Domain Keys Identified Email, is at the RFC was published back in 2007. So it's also quite an old standard. And DMARC, Domain-Based Message Authentication, Reporting and Conformance, was published. The RFC was published back in 2010, so it's even older, 24 years old. And then authenticated receive chain ARC. Let's talk about these different protocols and the usage scenarios. So first of all, SPF. SPF uses the text record in DNS, or you should use the TXT record in DNS, another TXT record, to validate or to specify the valid sources, all the sending systems who are allowed to send email in with your domain as sender. So let's say you have contoso.com. You would specify the text record as v equals SPF1. That's always the same. And then you could use include SPF protection outlook.com. That's another host. That's a reference, like a CNAME. That's a reference to another SPF, to another protected, or to another SPF hosted in this URL. Another SPF specified in the URL, and then you specify what to do. Minus all means you exclude all other systems. You could also specify IP addresses in this text file, which isn't part of this example now, like IP4, and then specify the IP4 address of the allowed sending servers for your domain. So if you are hosted in Exchange Online and you don't use any third-party, let's say, newsletter tools, then normally include SPF protection outlook.com is sufficient. And with this, you specify who is allowed to send in your domain's name as a sender. And you could specify the hard fail, minus all, or a soft fail, that's the tilde all. If you would like to have help in creating this text record, there are many SPF record generators available. Here's just one reference I sometimes use. You could add there the IP4 addresses, and you can add other SPFs and so on, and it will then create your text record, which you can just copy paste in your public DNS server. If you aren't sure at the first time, you would specify a soft file and then later switch it to hard file. But actually, there is no real use if you have a soft file in there. That's just, you have then an SPF record at least, but it's not so trustworthy for the receiving system. The goal of SPF, as mentioned, is telling the receiving server, you are telling all the receiving servers which systems or which servers are approved by you to send from your domains. And there are still issues. It validates the sources only in the mail from domain, but not in the from address. So you could use during the SMTP conversation, you could use email from as a valid domain, which for your domain, which is specified, but then you could also specify the from address. The from address is the address part of the header of the email, which will be shown in the email client. So you would see this as sender address in Outlook as an example. So it's quite crucial that the from address, or it's quite a bad thing if the from address can be different. So SPF only validates the mail from and not the from address. That's quite an issue. And SPF breaks if you have server-based email forwarding, if you don't configure it correctly anyway. If you have, let's say, your MX record still points to on-premises and you do mail hygiene on-premises, and then the emails will be sent to Exchange Online, then the SPF would break if you don't configure it correctly to skip the SPF using enhanced filtering for connectors in Exchange Online. But if you have another system which you cannot control and it would forward emails, then you would always see the sending IP address of this forwarding server, and therefore it would break all SPF. And sometimes there is legitimate scenarios for this, so it's bad if it breaks then. And each domain and subdomain require their own SPF record. You cannot specify a top-level domain SPF record, which will be inherited by all subdomains. So if someone else is able to implement another subdomain from your parent domain, which you own, then they could send out email from the subdomain with their own SPF records. And another problem sometimes happening, you have maximum of 10 SPF lookups, DNS lookups, meaning if let's say this include here SPF protection outlook.com contains another 5 include, there will be an SPF record in this address, and this address could include another 5 include statements. This would then make, first of all, this is one DNS record, one DNS query. Then the next will have, in this example, 5 others. This means you already have 6 DNS lookups, and if there are even more domains available, then if you reach 10, it will fail the SPF lookup, and then SPF will fail at all. So if you have this scenario, then you could use flattening or other solutions. With other solutions, there are third-party solutions available which do this flattening automatically for you. You don't have to do it yourself, because flattening means you resolve this IP address and all recursive IP addresses below, and then add all these IP addresses as IPv4 statements in your SPF record. Then you have many IP addresses in your SPF record, but there is no DNS DNS lookup involved afterwards, so everything is fine from this perspective. But you need to be aware if one of this you manually resolved DNS or IP addresses changes, and if this changes without you noticing it, then your SPF could fail again. And that's what other third-party solutions can solve, because they have the dynamic SPF record. You would host a dynamic SPF record, and this dynamic SPF record means they will check for DNS updates and IP address updates and hand back to the asking server IPv4 addresses. So that's one possible solution for this. Then we've seen how SPF works, and how to implement it is using this text record. But you need to know all your sending servers or your sending systems. If you don't know, or if you are not sure, we could use DMARC to solve these problems, as we will see in some minutes. Next standard, DKIM. DKIM, the goal of DKIM is to ensure message isn't altered in transmit, because it will add a signature and the proof that it's from an approved system from you. So that's another possibility of approve. Approve means you will sign the message with cryptography. Again, you will sign the message or the message body, and the signature will be stored in the message header of the email. So DKIM signs the elements of this message and stores the signature in there, so the receiving server is able to sign it again and compare the signature, or to prove that the signature is valid, because you specify the keys in your DNS again. So it's you specify which are valid signature keys in your DNS server. So it's implemented using DNS text, another DNS text record. And if no key provider is available, then your text record would hold the public key to verify the signature, meaning you would then, the receiving server is able to verify the signature, because you publish your your key in your text record in public DNS. This would look like this. We have the DKIM entry, resource record, big email, domain key example.com, and then you have the text, and the contents of the text record is DKIM1. That's always the same, and then P equals, and then following the public key of the signature certificate. And that's why we can check, or the receiving server is able to check the signature if it was tampered with the contents of the message itself. So that's if you host it somewhere else, but if you host it in Exchange Online, then Exchange Online hosts the selectors. These text records are called selectors, hosts the selectors for you, meaning you don't have to do anything with the cryptography at all. So we only have to add the selector1 domain key to your public DNS. This would, for ChangeCockpit.ch, this looks like this in public DNS. We have a CNAME record. It's not a text record anymore, because we tell the system to where the text record is stored using the CNAME. We have the selector1 pointing to selector1 in ChangeCockpit.onmicrosoft.com. So that's hosted by Microsoft in my tenant for me for free. It's included in the license. And another selector2 pointing to the hosted selector2. So I don't have to do anything with cryptography. That's why implementation in Exchange Online is very, very easy. So you have these two options. If you have a third-party system, or you do your own DKIM implementation, then you would add this text record containing the public key. And DKIM can validate messages that fail SPF. Makes sense. Let's say you have an email forwarding in between, and this email forwarding doesn't change anything in the message, then the signature would still be valid after forwarding the email, but the SPF would fail because the sending IP address is not in your SPF record, but DKIM sees, oh, this is still valid. It's trusted because it can be verified against the public key in DNS. But the issue here I just mentioned, if the intermediary solution does not alter anything in the email message. Let's say your MX record is still pointing to on-premises, and you have your own mail hygiene solution, anti-spam, antivirus, and so on premises. And let's say you would like to prepend the subject of the email with marketing, or with bulk, or with spam, if the email is detected as spam, bulk, or marketing, or other categories. Meaning this intermediate solution prepends the subject. Prepending the subject breaks the DKIM signature, because that's part of DKIM signature. And therefore, when this email will be received in Office 365 or in Exchange Online, then DKIM signature broke and could not be verified. And if you then also didn't configure the enhanced filtering, then SPF and DKIM will fail anyway, and therefore you would then see this email in Exchange Online protected as spoof, or as comp auth equals fail. So that's the problem with DKIM. We have seen the problem with SPF, with forwarding, and so on, DKIM. But these solutions are not coupled together as long as you don't use DMARC. It's just the receiving server or Exchange Online Protect checks for both, and adds both to the measurements of if it's spoof or not. So how is the implementation in Exchange Online? It's very, very easy. First, you need just to get the CNAME selector records. You go to security.microsoft.com/dkimv2. You will then see this portal in here. You will go to the security, to the Defender portal. You will see all your domains. Select the domain you would like to enable for DKIM. It's currently disabled. We see this in here. And down here, you see inside the red rectangle, you see the two selectors you need to add to your public DNS server. Add these CNAME records to your public DNS and wait for the propagation of DNS to finish, and then click on Enable. It will check if the CNAME records are available, and if Exchange Online can find the CNAME records, it will then turn on, and starting from this point, all outgoing emails will have an added DKIM signature. If it cannot find the resource record or the CNAME records, then it will throw an error which CNAME records cannot be found or is not correct. So that's it. That's the implementation of DKIM for outgoing emails in Exchange Online. That's only available for outgoing emails. That's not like DANE or MTA-SDS, where there are two parts, because only you as the sending authority. If you have a third-party system, let's say you have a third-party newsletter system where you send out your mass mailings to your customers, then you would get the DKIM records from this system, and you would add this to your public DNS server. You can have many DKIM selectors inside your public DNS. So you can have multiple outgoing or multiple sending email systems, adding DKIM signatures to the messages, and you just add them to your public DNS. If you have an on-premises Exchange server, there was available, or there is still available for Exchange 2016 and 2019, the DKIM signer. That's not from Microsoft, that's from another programmer who used it, but he doesn't develop it, he doesn't continue developing this signer anymore because they switched to Exchange Online and everything is done there. If you still have Exchange 2019, you could use this. I mentioned this here because it's I've seen it many times out in the field. Or you have your third-party Mailflow appliance or your third-party email newsletter system, then you just added the keys in there. Then we have DMARC. DMARC combines DKIM and SPF into a policy. I mentioned it before, it's loose, but with DMARC, we can specify who and what happens with the emails sent from your domain. If someone else sends or impersonates your domain and sends with, let's say, I want to send emails out with rolf@microsoft.com, and Microsoft specifies in their DMARC record what to do. So first of all, it checks mail from addresses if they match. So this issue from DKIM and SPF is solved with DMARC. It specifies actions and the policy according to it, and it is implemented again, surprise, using a text record. And this text record would look like this. It's _dmarc.domain, and it will then specify v equals dmarc1. That's always the same. Then we have many fields available. In this case, it's P means policy equals none. That's actually not that good, but at least there is a DMARC record. And then we have RUA, and there could also be RUF, meaning where to send. I'm still in the validation phase with this record, where to send the reports. That's like with the with the reports we've seen before. The receiving system, if you have DMARC published with RUA or RUF email address, then the receiving system like Microsoft or Google will send back every day a summarized report to this email address, so you can analyze if someone else or if a legitimate system which you forgot to add to SPF as an example exists, and um, then you can add them accordingly or correct your records. So that's in this case, it's policy equals none. You could add policy equals quarantine or policy equals reject. So Google would, if you have policy equals reject, and you would, if I have policy equals reject for ChangeCockpit.ch, and you would try to send an email with the sender Rolf at ChangeCockpit.ch, then it would be rejected because you wouldn't fail SPF perhaps, but also DKIM. And then ASPF is also sometimes used. That's the how the alignment should be, and you could have the MX toolbox, the DMARC record generator, all the fields, or we will see more fields right next. And we only have one issue here with DMARC: legitimate services that modify messages in transit before delivery break SPF, DKIM, and therefore also the DMARC checks. But we can solve this issue. We will see just in some minutes how. First of all, DMARC tags. There are many tags available. I mentioned the P equals the policy. I mentioned the ASPF represents alignment modes with the mail from alignment and the headers. And you could have the same for AD-KIM. So just have a look at what would you like to configure. Normally, we go with the default values and use P equals. So how would we do this, the implementation? We first go in there, implement SPF and DKIM for all known systems. We add all known systems to SPF, and we add all or we enable in all known systems DKIM. Hopefully all of your systems can use DKIM. And if they are not mass mailing to external recipients and they are not part of the external recipient rate limit, which will be enforced in Exchange Online next year, then you could even relay them through Exchange Online. Then you add first policy P equals none, meaning you have a DMARC policy, but nothing is done, and you add a RUA and RUF email address, so you will get the summary records to analyze the DMARC reports. You can then use, normally we use a third-party DMARC report analyzer, like I personally use Volleymail, and then you let it run for, let's say, 30 days, and then you go to this analyzer reporting software and check for which systems failed to have SPF and or DKIM, and you check if they are legitimate and you want to have them sending emails with your domain as sender. Then you add them to your SPF and or DKIM, enable the configuration, and then you would wait for another 14 to 30 days, check the reports again if everything is fixed. And then when you think, okay, now I got all systems which need to send out emails from our domain have sent domains, and therefore we got the reports back and could analyze the reports. We are sure now we got everything. Then you set P. I think I recommend P equals reject, because reject means an NDR at the recipient will be generated. If you send out an email and you fail SPF or you fail DMARC and P equals quarantine, then the sender thinks, yes, email sent, everything fine. And the recipient thinks, okay, I didn't get any email because it's in quarantine. The recipient can't just see it by now, and so no one knows what's happening. If you have P equals reject, then I send the email, I get the NDR bug, and I call my IT admin, hey, I got an NDR, and then so hopefully they will see the error and help me how to send out this email. There are also inbound policies available in Exchange Online Protection. We have DMARC in the anti-phish policy. You could specify if the sender specified P equals quarantine as policy action, what do we want to do? By default, it's quarantine the message. You could also set P equals quarantine still to reject. And if the message is detected as spoof and P equals reject, then we also want to reject. You could change this behavior, but then it doesn't make sense because the sender or the domain owner should specify in the DMARC record what to do, but you could overwrite it if you would like to do so. And then in the anti-spam inbound policy, we have the option SPF record hard fail if we want to hard fail the emails if they really hard fail in there. By default, that's turned off. Then what do we see in the header? If we analyze a header of an email, we have several things about SPF. I think the most important or the summary of everything is in the authentication results part when it's arriving in Exchange Online. You see in there SPF is pass, SMTP mail from equals ChangeCockpit, and DKIM is also pass. This means that comp, auth, and DMARC was pass, and comp auth, that's composite authentication, that's over everything is pass, and comp auth path means there was no phishing or no impersonation taking in place. Comp out equals fail normally means that the mail goes into quarantine because it's detected as impersonation. This is just for your reference. The email flow, what Exchange Online is doing with SPF and DKIM and DMARC in combination to finally have a DMARC pass. I won't go through everything in here because it should be hopefully clear by now what's going on. Then last but not least, we have ARC. ARC solves the last issue with DMARC when legitimate services change something in between when relying mails. So let's say we go back to the example, your MX record is pointing to on-premises. You have your own mail hygiene solution. This anti-spam solution then prepends the subject. It prepends the subject. This means it will break DKIM. Then because of this, it could or it will have comp auth equals fail, and all emails in Exchange Online arriving in Exchange Online will go into quarantine or junk. So with ARC, you can solve this issue because you can have ARC authentication, an ARC seal added in the intermediary station. And therefore, you know that emails coming from this ARC seal or this are valid. ARC solves this problem, therefore, with breaking DKIM and SPF, and therefore DMARC. You can implement ARC in security.microsoft.com/authentication. The only thing you need to do is to add the domain where you would like to have the ARC, and Exchange Online Protection then uses the original ARC seal. Means we don't just say we trust this guy, everything that's coming in from here. We would then use the original email authentication information, which the ARC sealer adds in there to validate the message before. So we would somehow look like it to this message like we are the intermediary, and therefore we would see valid DKIM and valid SPF records in there. So we the ARC sealer provides all this what we need to validate when it comes into EOP. We see this here in this chart, or with ARC seal, the email goes to your on-premise system. We have the third-party appliance. The ARC seal will be added by this appliance. Admin accepts the third-party ARC seal, and therefore you need to accept it when doing the configuration. And therefore everything here ARC equals pass, meaning and accepted DMARC fail, but spoof equals pass anyway because ARC equals pass, and therefore you would see comp auth in the header. you would see comp auth equals pass with the reason equals 130, and not normally it's reason 100, but if it's reason 130, then you would need okay, arc is it was passed because of arc. And we see also the authentication results, SPF equals fail, DKIM equals fail, hash did not verify, but comp auth equals pass would be strange if both of this fails. And the reason is 130 means the ARC authentication results are fine. We trust it. Everything is good. So that's only needed if you have an intermediary solution which changes or alters content, which breaks DKIM. If it doesn't change anything, then using enhanced routing configuration in Exchange Online to add the intermediary IP addresses to skip from SPF is sufficient. You wouldn't need ARC for this scenario. ARC is only needed if DKIM also breaks in the intermediary. I'm only talking about Exchange Online configuration. That's it for ARC. That's a deep dive of ChangeCockpit. But anyway, what is ChangeCockpit? For our guests in here, for the members, they know because it's a service primarily for the members. First of all, ChangeCockpit is a monthly live event containing all updates in Microsoft 365, all updates, which are rolling out in the current and following month. So I do a live presentation about currently around 100 changes which are rolling out in the current and the following month. So you know everything what's going on in Microsoft 365 regarding changes rolling out. There is, if you think, okay, I want to see this, then just go to changecockpit.cloud and ask for a free demo. Then you can join the live session. Every company can join the live session for free one time to have a demonstration. And here you also see some of our amazing customers, which are already part of ChangeCockpit. Next events, Wednesday, that's in a week from today. I don't know when you're watching this, but Wednesday, 23rd is the Swiss-German version of ChangeCockpit in the morning, 9:30 until 11:30. And in the afternoon from 3 to 5 p.m. It's the ChangeCockpit English version. Yes, it's available in Swiss German, it's available in English, and if you have a company which can use both, it doesn't matter because in the subscription, both languages are included. And then we have the next deep dive, Get in the Loop. It's all about Microsoft Loop on October 29th on Tuesday from 9 till 11. And then we also have more. We have just announced Get in the Loop. And then we have MFM phishing resistance in December 10th. And then on the 9th of January next year, all about multi-tenant. Yes, this was moved to 2025 for those of you who have seen this before and think, okay, why is multi-tenant? Okay, no, it's in January. And then in March, as SharePoint Online Advanced Management. A recording is available. Either you are watching the recording, so you probably accessed it in Teams because you are a ChangeCockpit member, and guests get the link when signing up through the landing page. And we also have other resources from my fellow MVP with msb365.blog. Q&A normally, because it's a recording here, I say you can ask your questions, either chat by Teams or send an email to this address. And if you would like, please add me and Drago on LinkedIn using these QR codes. Then thank you very much for listening to this point. I hope you learned something. I hope everything is clear now regarding these email security aspects. And I wish you all a nice rest of the day, week, month, or whatever you prefer. Thank you and goodbye.